Today we will look at the conceptual part of drawing the graph of f of mod x when the graph of fx is given or how this graph should come into your mind automatically. So first we take a general graph of y equal to fx. Okay, so we take some general graph as y equal to fx. Now we should know the graph of y equal to f of minus x. So f of minus x, okay. So whatever value the graph is taking for a particular value of x, it is going to take at the value of minus x now. Okay. So the resulting points will be mirror images on y-axis. So on joining these points, we will get mirror image of the right hand side on left and left hand side on right, which I haven't drawn because our purpose is to draw the graph of y equal to f mod x. Now f mod x will be defined as fx when x is greater than 0, that is on right of y-axis, and this will be f of minus x when x is less than 0, that is left of x-axis. Okay, so the graph remains as it is on right of y-axis, and on left of y-axis we take the image of portion of graph on right on the left. Okay, so we draw only the portion of graph right on y and take its image on y. We don't need to draw the graph on left. Now we will see certain examples. Okay, we draw the graph of y equal to x squared minus 5x plus 6. Now we will remove the portion left of y-axis, or we don't need it. And we will take the image of portion of right on left of y-axis like this. Okay. So this gives you graph of x squared minus 5 mod x plus 6, which is of the form f mod x. Okay. Now we see our next example, y equal to 3 minus x. Now this is the line y equal to 3 minus x. We will remove the portion left of y-axis and take the image of portion of graph on right of y on y-axis. Okay, like this. We remove this part, we take its image. Now we see that this is the final graph that we get. Now we see the graph of a cubic. So first we draw this cubic, then remove its left part and take the image of right part on y-axis. So the major rule is you draw only the portion of graph right of y-axis. You don't need to draw anything on left and take its image on y-axis. Now we will see certain examples. So the first example is y equal to sin x. Okay, so we have drawn the rough graph of y equal to sin x, and to draw the graph of sin mod x, we just draw the part right of y-axis and take its mirror image on x-axis like this, something like this. Okay. So this you get as graph of sin of mod x. Okay, it doesn't remain periodic anymore. This is a point to be noted here. Now for y equal to log x, to draw the graph of log mod x, we take the image of portion on right on y-axis, something like this. Okay. So log mod x will have the domain all real numbers except 0. So even if log x does not have any portion of graph left of y-axis, log mod x will have the reflection of portion of graph on the right axis on y-axis. Okay. Now we will see specifically what's the case with the quadratics. Okay. So first we see a quadratic whose both roots are positive. Okay, so a quadratic with both roots positive is drawn. So for drawing only its p mod x, okay, putting mod only on x, we take only the portion of graph right of y-axis and draw its image on y-axis. Okay, so a quadratic which has two positive roots, the p mod x is going to have 4 roots total. The 2 positive ones will remain and 2 new roots will come, which will be mirror images of these 2 roots. Okay, when the original quadratic has 2 positive roots. Now in the next case, if the original quadratic has one positive and one negative root, like this. Okay, so to draw the graph of its p mod x, we take only the portion of graph right of y-axis and take its mirror image on y-axis, something like this. So if a quadratic has one positive and one negative root, its one negative root will go off. Okay, the positive root will stay and another root will come, which is mirror image of this positive root. Okay, so you can make a rule for all quadratics that if the original quadratic has positive root, its f mod x will retain that positive root and give an extra root which is a mirror image of that positive root. And if it has a negative root, the original quadratic, that root will be gone. That will not be a root of f mod x. Okay. Now we see the last case where the quadratics, both roots are negative, like this. Okay. So in this, we remove the portion of graph left of y-axis, so we retain only the portion right of y and take its mirror image, something like this. So both the negative roots are gone. Okay, so and another very important property of f mod x is, since its mirror image on y-axis always, f mod x of any function is always an even function. Okay, because if you put minus x instead of x, you will get back the same function. So any function of the form f mod x is an even function. Okay, so for more such concepts, new problem, new ways to look at problems and new ways to solve them, keep watching further videos. See you in the next video.